السلام عليكم جميعا. Good morning. My name is Abdelmajid Al-Alawi and I'll be your host today for the Siemens workshop session. It's titled Driving Productivity and Efficiency Through Advanced Manufacturing and Digitalization. We're delighted to have you all here in SIDF headquarters and to everyone joining us live. Welcome. Today's session is held in collaboration with Siemens, a global technology leader driving innovation and transformation in the industrial world. For decades, Siemens has been at the forefront of advanced manufacturing, more connected and more sustainable operation through digitalization, automation, and energy management. Throughout today, we'll explore how Siemens' digital manufacturing ecosystem enables organizations and companies to achieve higher productivity, flexibility, and efficiency, paving the way for the factories of the future. Introducing the Siemens team now, and it's time for our workshop to begin. Please join me in welcoming our colleagues from Siemens, who will lead today's session and share valuable information and insights on how digital transformation is reshaping manufacturing, both globally and here in the Kingdom. Please welcome Mr. Maez Al-Isber.
شغل لي السبيكر. اوكي تمام. تست. اوكي. السلام عليكم جميعا. اسعد الله صباحكم. First of all, thank you very much for the invitation. We are really delighted to be here today with SIDF and in particular to be in the Kingdom. My name is Maez Al-Isber. I'm part of Siemens team in the region, and I'm taking care of the technical sales management for the MENA region. So I'm here to welcome you, of course, along with my two colleagues, Mr. Ahmed and Mr. Imran. And we believe, inshallah, today we will shed light more on how Siemens is helping to basically shape the industry, the technology, and secondly, how the local manufacturing in Saudi Arabia can benefit from these technologies. So with that, let's start the slides. So Siemens in Saudi Arabia, I think this is what it matters, and this is where I just wanted to shed 2 minutes of your time where we are in here. As a Siemens, we've been in this business for over 175 years. And when it comes to Saudi Arabia in particular, we've been over 100 years in here. The first business ever was done in Hijaz. This is the first line of, telecommunication was done. All the way, shedding history to 2024, where now our third factory is integrated in Modon. That reflects basically our in-country commitment, our when it comes to the value that we want to add to the Kingdom of Saudi Arabia, and of course, to elevating the talent of the nationals in Saudi Arabia. Our goal, as per our latest CEO slogan, is to create sustainable value. This is what technology is about, right? And when it comes to sustainable value, that means a couple of topics that today we will discuss when it comes to green, lean, and basically a technology with purpose. So as a really quick, when it comes to Siemens, perhaps some of you have heard of it when it comes to gas turbines, steam turbines, digital transformation, automation, electrification, even all the way to your microwave, to your basically home appliances, to your phone, to your mobile phone. So we have a lot of history when it comes to different industries, and the added value when being involved in all of these industries is how we can move technology from an industry to another, and how industries can learn from each other. And this has been crucial for us to know how enable technologies that are mature in an industry, how to move it to another industry that is not mature or it's not even existing over there. So when it comes today at the core technologies that we will discuss in particular in this workshop, we have a couple of main technologies that are now, when we speak Industry 4.0, even now Industry 5.0, we have these technologies that we have to think of, especially digital twin. Now, everyone have heard digital twin, AI, connectivities, automation, robotics, additive manufacturing, subtractive manufacturing, and more importantly, on top of all of this is what is the cybersecurity related to this domain. So today we will shed light quickly on these technologies with some use cases and with some actual references on how Saudi can benefit from this. So basically, the mega trends that we see today in the market, back on the previous slide that we mentioned about the key technologies, are mainly related to digital transformation, big data, AI, how we can mine the data, how the data. If you look today, the most valuable companies in the world, of course, are related to, Google, Facebook, Meta, all these companies. It's really about mining data and making use of the data. The second point, especially with the Saudi commitment to net zero in 2060, is related to the net zero and decarbonization. How we can be more green, more sustainable for the future generation. And of course, that cannot be done without developing the skills that we have in the kingdom and globally. One of the key points that we noticed over the years that there is, what we call roller coaster effect on the skills that are required to boost this industry. So one of the key points in any technology is how we can move this to make it usable by human. And this is where making it simple is key. And finally, of course, especially for this region and the conflict we see in the world, how technology can help in minimizing the geopolitical changes and instability, all the way from the COVID that we witnessed in the last 4 or 5 years to the geopolitical tension that we have currently with the region. So those are the main mega trends that we see driving the technology and the industry, and Siemens is on top of it. So today, there is always a saying, what is the factory of the future? How today Saudi, SIDF, and the industry in Saudi can take it to the next step. So if we want to summarize it quickly, there are at least 20 to 25 different technologies, main pillars, what we call it, on how we can cover end-to-end value chain when it comes to digitalization. Right? All the way from the raw material part, how you source your raw material, how you ship it, how you clear it, how you manufacture it, how you package it, how you process it, and then even how you distribute it. All of these technologies make it difficult for companies, even tier 1 companies, to select which technology shall I use, which project should start first, at what pace, does it make sense from a financial point of view to invest in these technologies? Are these technologies really the right match for my processes? A lot of questions that we face, tier 1, tier 2, even with tier 3 companies, okay, does it make sense or doesn't? And this is where we thought that, digital transformation is no one fit for all. It is a tailored approach because it takes into your consideration your objectives, your KPIs, your challenges, your existing landscape, and of course, your future expansion or future development plan. So now I will shed some light on a title that is close to my heart because this is where I started at Siemens. I started 5 years ago as a digitalization consultant, and I've been blessed even to work in Saudi with a lot of companies on this, and in UAE and Jordan. And it was mainly about green, lean digital factories. The question was, I'm a factory owner, I'm an operator. How can I maximize the utilization of the available resources? I don't want to make mega trend when it comes to the investments. I don't want to really come with something that is totally, heterogeneous for my setup, yet I want to double my productivity. I want to reduce my basically my operating cost. I want to basically cut off all the fat that I have in the production, reduce my, waste, etc. A lot of questions that been, and this is where Siemens, along with a lot of tier 1 consultancy firm, came to an agreement. Okay, we need to work it out. And this was at the time even a cooperation between Siemens, BMW, McKinsey, as well as to create something called Siri Index. I'm pretty sure that you are very familiar with Siri. And this is exactly the point. So I said we're going to create a framework, a methodology on how we do it in a systematic way. So typically it is about 6 steps, starting with awareness, what is Siri, smart industry readiness index, how to do the assessment, how to draft and design the digital strategy for each factory on how to transform, to do the financing part, and thanks to like SIDF and mashallah, the kingdom, when it comes to the part of boosting this part, has been a role model for the region. We see it because what has been seen in SIDF or Future Factory programs or other programs that are available in the kingdom are really a role model, not only for the region, even globally. And of course, when it comes to the implementation, last thing that you want to do is, I know what to do, I know how much it costs, but I'm not sure on how to implement it, right? And finally, how we take it next step is to optimize and innovate. So what we call really is a journey. Digitalization, as I said, is not one fit for all. And definitely it is not a project that we do today, it's done. Right? It's like going to your gym. It has to be always daily till, I don't know, till you can walk to the gym. So digitalization journey is no different. It's a journey. It starts where you are, regardless where you are. And it only ends where the technology can stop helping you. And as of today, it's not the case. The technology is evolving so rapidly that even as an industry, we're struggling to catch up with the technologies. So therefore, we are being a bit selective on which technology makes sense, because there is typically a CapEx and OpEx commitment when it comes to technology adoption. So typically, what we call this is pre-digital plant. And this is where most of the industry is, right? We had the revolution, industry revolution 1, 2, 3. Most of the companies today within electrification automation, they are mature, and this is where they stand. So this is where typically we speak, okay, before you digitalize, you have to digitize. This is where we start talking about connected plant. And then this is where we help our customers from being from, reactive approach to proactive approach when it comes on the operational planning, maintenance, all aspects. So this is where we go to predictive plant. And finally, the goal with the boom of AI technologies that we have today is to move to something called autonomous plants, which basically a plant that is self-aware of itself. Operation can speak to maintenance, can speak to utilities, to transportation. It can understand if there is a bottleneck and react based on this. And in most of the cases, the human role is more of a supervisory role. We're not waiting anymore for a human to come and to push a button to fix things. So basically, it all starts with the SIRI assessment, which is basically, it's even adopted by SIDF in here, and in the kingdom, it's highly basically recognized. And we have helped a lot of customers to basically to do their SIRI assessments and have multiple focuses and dimensions. You know it very well. I will not really go into details. But this is, I think this is a good starting point, right? If you have any challenges, health challenges, for instance, when you go to the doctor, the first thing he's gonna tell you what? Do a medical checkup. Just give me basic reports, blood or whatever is the case. I know I wanna take your vitals. And this is what we believe SIRI is, taking the vitals of these factories. Second point is basically after we do SIRI, okay, so we know which band and how much is your score in each band. The challenge that we saw with our customers in that particular is, okay, so I have 9 projects or 8 projects, whatever the case. Which initiative I need to start first and in what order, right? So a lot of these questions will be, will be coming into to our customers. How can I move it next step, etc. And this is where basically we thought, okay, doing the SIRI itself is only the start. We need to take it full. We need to help the customer to do even the roadmap, and from the roadmap to develop a full operational and financial, basically what we call prototype for these projects, check the viability for this project for this customer, and then even help with the optimization. And typically those projects are about 2 main topics. How can I converge the operation technology I have with the IT technology I have? This is where we are able to capture all the shop floor information, merge it with the top floor information. So as a day-to-day operator or a decision maker, you are able to make a fact-based decision-making process, be it on your productivity, on your waste, on your overall equipment efficiency, and a lot of topics that could come along. So basically, as I said, it's a green, lean, digital. A green, of course, as I said, is no more an option, is no more nice to have when it comes to sustainability, right? And Saudi, mashallah, is a front runner when it comes to the green aspect sustainability. Lean, basically, is we have to focus end-to-end value chain It's not only about me receiving the raw material, it's the full distribution cycle from how I receive the raw material to how I distribute my finished goods. And of course, digital. There are a lot of technologies today that can help optimize and improve my efficiency. So combining these three aspects in any project for the industry are key to make sure that if we are doing digital and lean, we're not neglecting green, because green is a key factor, so on and so forth. And this is what we call in Siemens, the diamond triangle. So typically, back to the same point, is the first with Siri as is, and then the discovery part, the acceleration part where, we start pinpointing solutions. This is where now, after we do POCs, POVs, and the transformation starts, and once we see this is viable, then this is what we call scale-up phase. So we take this technology that has proven value for this specific customer, we scale it up. And of course, how we do the network transformation. What we call network transformation is how we transform the business today. We all remember how things used to be when it comes to paying your electricity bill or water bill only 5 or 10 years ago. Today, it's just push of a button, right? And this is no different when it comes to the industrial sector. It's worth mentioning that Siemens owns over 130 factories globally. This is where we manufacture our own hardware, that you see it everywhere in your day-to-day life. And this technology or this methodology that I showed you today was applied for our factories. This is where we started, because we recognize that we need to do it ourselves, we learn it, master it, and see the value out of it. And since 1990, we were able to optimize or improve by 13 times our production capacities. I'm speaking, by the way, about the same plants. We have not added new lines. We have not built new ones. It's about the same plant itself being able now to produce more efficiently, less waste, with less, I would say, human-intensive involvement. And the quality that was anywhere between 80 to 90% is now 99.99%, which is now what the market is requiring. And the modularity, we have over 100,000 products within Siemens. Why I'm mentioning this? Because within Siemens, with the innovation that we have in the market today, the need to have the capacity and the ability to produce new stuff within a matter of months is crucial. And today we're going to speak more about the digital twin topic, how I can start product from ideation part to the production part. So we need to shorten this, because time is money, as they say, and especially when it comes to these products. After the challenges that we had in the supply chain, stock needs to be there always. This is pretty much just an introduction. And this is what I always said. Before you start building your digital transformation roadmap, perhaps it's worth it to take a step back and try to design a whole concept instead of just focusing on specific projects. This is another slide that is something I'm dealing with on a day-to-day basis. As I said, now on the digital twin aspect, we all start from, a virtual product, right? And then I design this product virtually on a screen. And then to build this product, I need to design the SOPs and procedures. So this is where I start even designing a virtual operation. So as of now, I have designed the product. I have designed the SOPs and the virtual operations in a risk-free environment. I've done multiple runs of different scenarios just to make sure I'm very cautious about all the aspects, what is needed, what are the requirements. And then I move this to an actual operation, and then I end up with actual products. This used to be anywhere between 8 to 13 years between R&D till final products. Today itself, we're talking about months of time. When it comes, just imagine that you build a house, and after you finish the house building, you realize, this room should be there, not there, or the ceiling, or the door, or the window, whatever is the case. So you demolish, start again. Now with the digital twin technologies, the technology is able to provide you what we call a risk-free environment to run multiple scenarios to test different possibilities. So here I'm just going to shed based on the local experiences that we have done, what was the yield, right? especially when it comes to chemical processing factories. You see the numbers speak on themselves when it comes to how to design a catalyst, right? Especially when it comes to the refinery business and to the chemical industry business. And basically how to optimize the design of catalytic reactors. For instance, this is a $15 million savings on a contractor design. Right? This is to make sure that I have the harvest efficiency and the lowest complexity in the system. For the hydrogen process, and mashallah, Saudi is as well a front runner when it comes to the hydrogen part. The ethylene yield, the control of polymer production. So speaking about very technical, deep operations and processes that requires not the high-level digital twin. I need a digital twin who is able to mimic my operation, how the chemical reaction happens, how the physics happens. And this is today available within Siemens. This is just a quick, example on how basically for a complex of gas steam turbines, how the emission control is and optimization is done. So basically, technology today, with the technology, you are able to model your gas, steam, your burners. You are able to model them, operate them in sequence, and then optimize the yield based on the demand that you have from your operations. This is only a glimpse on how it can be done. One of the key points that typically are required is for any factory today, you have information on your ERP for finance, HR, warehouse. You have information coming from maintenance. You have information coming from operation. You have information coming from the spare part team. You have even information coming from the safety team. All of these information. Sorry. And even I have operation when it comes to the supply chain part, right? How many parts I have, what is the cost, etc. So just let's think together. How many dashboards, how many systems, me as an operator, as a decision maker, as a manager, even as a shop floor engineer, I need to access in order to know specific information. Typically, it goes anywhere between 5 to 10, 12 systems. It depends on the complexity of the setup. So there was a big push within Siemens, and most of these technologies are used by ourselves in our factories. So there was a big push that we need to minimize this. It doesn't make any sense. From me as an end user, I need one interface that is able to speak with all these data sources, contextualize this data, make sense of this data, and then make it in a different dashboards that are made available to the different functions within an organization. And this is crucial. So basically, you see here an example of a system that is able to cover all the way from production, asset reliability, maintenance, inventory, quality, safety, the energy part. Even if you have equipments that are moving left and right center, all of these needs to be in one place and accessible. And the second point that always comes to mind, okay, now I have this information, but I am the guy on the field. I am the guy who's doing the day-to-day job. Shall I carry, karras wara my wherever I go, for instance, or a pack of paper wherever I go? So this is where we said, okay, we need to move it next. I need to make this full digital, not only on data contextualization, but even on how the data is being accessed. Now today's, with certain technologies within Siemens and in the market, with a simple scan of a machine, you are able not only to know the operating condition of the machine, even how many times this machine has been serviced, right? What is the history of this machine? When it was bought? What is the cumulative cost of repair today? There is a lot of questions that comes. Is it replace versus repair for a specific machine? Is the spare part available? Is there a work order, for instance, that is planned for this machine? So on and so forth. A lot of questions. And we see this especially when it comes to big complex where there is a need for the operator to be on top of the available information. So what we thought is we're going to bring all this information to the palm of the operator. And the same information that you have seen before is now made available for him with an image. He takes an image of the asset, all the information that he requires to populate. And not only that, as I said before, we are doing digital twin for a lot of things. And a key part of a digital twin is, especially when it comes to the new joinee, the newcomers, right? The fresh graduates that are joining specific industries, especially the industries with, I would say, harsh environment, oil and gas, for instance, chemical processing. So there was a lot of push on how can I do simulation of the training itself. So this is where technology as well, along with the digital twin, has been able to help our customers globally to do what we call, 2D, 3D modeling, to be able, as you can see in here, to do the full training for the staff, be it from the safety, from the operation perspective, even from what is, the first response in case of any incident. All of this done in, again, a risk-free environment. This is more details on how typically it works. And there was very recent as well a joint hand with NVIDIA, that Siemens and NVIDIA had put together some efforts to develop what we call today Omniverse, which is the industrial metaverse, right? And we believe this is crucial, not only on the safety aspect, even on the operation, on the training, on the way how we can elevate, preparing an entry or a job applicant to be ready to start the job in certain time. As I mentioned before, most of the times we've been always waiting for something to fail to fix it, right? Or we have to rely on someone walking by in next to a pump or to any rotating equipment and hear a voice or hear a noise or a cracking sound. Okay, this needs to be fixed. Now with the technology that Industry 4.0 is able to provide, we moved something to call predictive maintenance. So the system is able to read symptoms that are typically not detectable by humans or by regular systems. Put these symptoms together and evaluate what we call the fingerprint of this asset. In the sense, sometimes an asset could go wrong by additional electrical consumption. Sometimes go wrong by just heat because it's consuming more electricity, right? Or it could be noise. Or it could be simply not operating to the conditions that mechanically is meant to. For a human, this is difficult to, and sometimes, especially for mission-critical systems, you cannot, as an operator, as an industry, you cannot afford for system to fail all of a sudden. So this is where technology is based on AI and machine learning is able today now to predict days ahead that this machine with these operating conditions could fail in X and Y days. And this is crucial. This is changing the way that today we address our maintenance topic, for instance. Because what we have realized that despite doing preventive, which is something that, okay, I buy a car and then you go to the dealer said each 10,000 kilometers you come for a minor service and each 30,000 kilometers or 50 you have to do major, right? But that doesn't take into condition the way you drive your car. What if you are doing off-roading daily with your car? Does this still stand? Of course not. What if you're always between, mashallah, Riyadh and Jeddah, right? Going cruising 1,000 kilometers each way. Doesn't really stand. So since each operation is unique, having these preventive maintenance like schedule number of hours or number of days or number of production units is no more viable. So as we said, it's a green, lean, and digital. And one of the key topics we always want to highlight, especially for the future generation, for our kids, grandkids, and the future generations that gonna come, is basically, as an industry, be it process or discrete industry itself, we are responsible of 30% of the CO2 emission. This is high. But this is an opportunity as well. For us, this said that whatever impact that we do on this 30% will have a global impact on the overall CO2 emission. And that's why governments like the Saudi government, the region, and globally now are committing to a net zero strategy within the next 10, 20, 30 years. And Siemens itself, we're no different. Siemens has made a commitment to be net zero by 2030, which means we have to replace our CO2 footprint, going greener, leaner, right? So if we can save only 1% of this 30% emission of the CO2, we are able basically to take off 90 million tons per year. Only 1%. مشوار ال1000 ميل بيبدأ بخطوة. We need to start from somewhere. Despite energy is relatively cheap in the region, but the region is taking lead on this topic, because we will be one of the first to suffer from the consequences of the climate change. So how we typically are helping our customers when it comes to green, lean, and doing their digital transformation with their lean transformation, but from a sustainable aspect. So typically it all starts from how we can collect the data. I need to know, similar to Siri, and now Siri has a band related to, I would say, to the sustainability part. We need to collect the data, analyze this data, segment the consumptions that you have in different ways, so on and so forth. So in a nutshell, there is already a developed methodologies and a framework on how we can do this in a proper way that is recognized globally, especially that with the vision of Saudi export to international markets, be it in the GCC region or be it to Europe or to the Americas. Now there is more and more demand. I need to have transparency on your carbon footprint equivalent of each product that is coming out. And we see it from the fertilizer business to the cement business to the plastic business, polymer business. All of these are now coming to us, said, okay, how we can help, how we can have a roadmap, how we can measure the CO2 equivalent of my product so I can improve. I can show my clients that I am improving, because now with the market, the mood of the consumers are changing greatly. Now today, if you want to sell everything, you said, okay, this is, for instance, green. There was a hype before about organic. You can easily double your price of your product. You say this is organic. Now the hype, you said this is green. And it has a big financial impact on how companies are operating globally. One key aspect of this is, of course, related to the energy management part. And when I speak energy, it's not only electricity. It's gas, steam, charcoal, whatever energy source that you have. And, of course, solar. And basically having a system that is able to connect the information from all these data sources, to map it, to do a digital twin of these different systems, and to see the interaction of these different systems when it comes to the load versus what is generated is crucial. And this is where we as a Siemens are be able to help our customer from the sensor level to the solution, full solution level. This is an example on how typically we map different processes when it comes to the energy aspect, and how this will be reflected from an operator perspective, how that looks like in the real life. And this is crucial, because a lot of times, just looking to the numbers doesn't help. I need the system to tell me where I'm deviating, where things are going right, where things are going wrong, to what extent, is it acceptable, is this the optimum or not? And today, we don't have to rely on humans to do it only. There are systems are more capable, more adaptable to do this, and are available in the market. So this is here where I'm just shedding light on some of the examples when it comes to the retrofit that typically happens after any energy management design or roadmap for our customers. And bear in mind, gentlemen, ladies and gentlemen in here, any technology that we do has to make green, lean, digital, of course, but has to make financial sense. Down the line, these companies are about investment opportunities for the owners, be it private or public, right? And whatever I come to an investor, an owner, a CEO, or a decision maker within an organization said, you know what, you need a advanced energy management, or you need to do digital twin for X or Y, or whatever the case. The question, okay, it's nice to have a green, lean, digital, but what about the ROI? How can I quantify the value? And these are some of the examples. You see, a full retrofit for a factory that happened next door, and the ROI was realized in 2 years. Full return on investment in 2 years, which means 50% return on investment per year. No businesses out of today's when it comes to such an investment are giving this, to make it clear. And then you benefit from the technology for the next 10 to 15 years. So on and so forth. There was here another example of retrofit that has been done as well for another factory. And the ROI, again, was around 2 years. As of today, most of the ROI is between businesses 10 to 15%. If the company is doing very well, it will be 20%. But these technologies speak for themselves because they are mature technologies. Those technologies that has been tried, executed, and done on different systems, and it's all about that I know exactly what is the value, what is the impact of these technologies. So what I'm trying to say within these slides, digital is not just word expensive, no. Digital is economical. So it's not about the cheapest solution, it's about the most economical solution. It's about a solution, if I decide to invest in it today, I'm able to capture the value in the next 2 or 3 years. This is what it matters from an industrial perspective. Now, as I said before, we have a lot of technologies. And those technologies now, we are connecting shop floor to top floor to cloud. Now, from your mobile, you can apply for your sick leave and it's done. You have access to whatever information you want on your own drive at work. There is a lot of push that happened in the market when it comes to the IT cybersecurity part. Because we're hearing IT since we were in the universities. I think we are all pretty much the same age, except for the young ladies in there. 40, 50 age, right? So IT has been always there. Information technology has been always there. Firewalls, rules, dematerialized zones, sandboxes, this has been always there. But the more we realize the challenge is not really on the IT. IT is kind of secure. The problem we have is connecting these systems together created something what we call operational technology, OT. And now these OT are vulnerable. So whatever issue is coming from the OT, since OT is connected to the IT, is coming up to the IT, and then it's a mess. This is a nice slide I always like to see it. So whenever there is an issue, there is always a question. Is it the shutdown or shall I keep quiet about it? Right? Just shut down the machine, nothing happened. I received an email as I thought it is coming from an OEM to do a patch upgrade of my controller. I open it. It realized this is not a patch really. All of a sudden I have, weird screen on my operating machine. What I do, just turn it off. Is it fixed? Right? Perhaps the question, let's throw some information in here. Typically, if a company is attacked from an operator perspective or even from an IT OT perspective, how much time does it take for you as, I would say, a operator to realize that you've been attacked? There was a study done by McKinsey said that it's an average of 200 days, right? Just imagine, we need to push it a bit there. But as an average, it's 200 days for you to know that you have been attacked. 200 days, a lot can happen in 200 days. And there was always a saying when it comes to the industry, if it works, don't touch it, leave it. But it's not anymore. And we used to have the machines, especially in the factories, running on XP or I don't know, Windows 95, all of these systems. No more, it's no more an option. Most of the new now systems, we cannot afford to keep them on these old operating systems that are obsolete. They are not no more supported by any upgrade or any kind of follow-up from because now they want to sell the latest one. So how we bridge this gap? I'm not going to change a full factory operating system because it's no more supporting Windows 95 or Windows XP, whatever the case. So this is where, as a Siemens, we realized that. This is jumping again. That all the way from the 80s, this OT or this cyber attack started to be a real threat. Before people were, internet was not much there, speed was an issue, people did not adopt. However, from 1986 till as of today, and this perhaps needs to be updated with the latest big one happened 2023, we all heard of, I love you, I wanna cry, all of these kind of IT huge cyber attacks that happened, right? And that really cost millions and millions. And no one really knows what is the impact of these attacks that happened before. But the question is, can it be sorted out? Can it be prevented? To a great extent, it is. However, we cannot take the IT approach in approaching OT. Because IT and OT, despite now they are connected, but they are different. How they are different? Today, if you have a laptop from your work, 3, maximum 5 years, the IT will come, take it back. This is now obsolete. They will sell it, scrap it, right? They will give you a new one. Latest security updates, latest antivirus. In the industrial, it doesn't happen like this. I've been in factories still using Siemens PCS5, which is 45 years old plus. Operational. I'm talking with the guy, you want to change it? So no, it's working, why I need to change it? So keep it, right? So when it comes to the shelf life, the 3-5 years of IT doesn't apply for OT. Secondly, the forced migration. Now today you open up your laptop, despite you are in top importing meeting, whatever the case, there is an update from the IT coming. It needs to be updated, patch update, whatever the case. However, for the OT part, as far as I'm able to procure my spare parts, I'm gonna keep it. You know, when it comes to basically the option for the security, right? It's always top notch. Always for the IT, latest, antivirus, latest firewalls, latest rules. There is a full-fledged IT team taking care of the security part, right? But when it comes to the operating technology or industrial security, it's not the case. It's not being seen that. And of course, when it comes to the standards and to the heterogeneity, typically in most of machines today, Windows 10, right? Or if you have an OS, depends on whatever you have. But when it comes to the industrial sector, as I said, 95, XP, Windows 7, with all the different versions. So there is a lot of heterogeneity. So how can I really see the difference in here? What's the bigger, for the industrial sector, what is the bigger picture in here? This is a very nice display that I like to talk about. This is a typical enterprise industrial network. From a quick glimpse, you can see the industrial network, the OT network, is really the big one. This is in volume, in number of what we call tag points, in number of entries, in interconnectivity is much bigger than the IT one, despite the IT is covering mainly, the what we call that the enterprise layer. So what shield we put on this is all of these things, right? Time sync, security concept, user management, dual authentication, a lot of security patches. Right. For this big chunk on the industrial network that is really speaking with the machines producing what we have in there, barely anything. Barely anything as of today. And this is where we believe that there is a lot of work needs to be done to elevate the OT network, to avoid unpredictable shutdowns. One thing I always said that having a safe, secure network, you will realize the value of it once you are attacked. Unfortunately, most of the companies who learned the value of this learned it by experience. So they went through the learning cycle. But it's not needed really. There are now standards, international standards that are available in the market. Companies fully focused like ourselves on this. We know OT, we know automation, electrification, we know IT. We can make sure that those two parts are properly integrated. So basically, just wanted to give you as well, typically, how an OT, what we call design architecture is done. How we help our customers, how it is conceived today in the market. So basically, there are about 5 phases. It starts where I am today, where do I stand? So someone from the expert team has to come, have a look on your factory, identify from a connectivity perspective where you are. This is the starting point. And if you recall, we have done the same for the green, same for the lean, same for the digital. The first thing is I know where I stand, right? And then it goes, where do I start? Which area is the more, I would say, vulnerable one? Which is the area is the more exposed one? Where it is nice to have, must to have, where it is a red light, a green light. And then, which assets are, as I said, mission critical assets? Those needs to be high availability, high redundancy. I cannot afford these to go down by any second. Just imagine for a second. You are in a steel factory or a glass factory. And we all know that there is a furnace in these factories. And for your information, these furnaces doesn't go off. If a factory has been running for 40 years, it means this furnace has been there working for 40 years. Doesn't stop, most of the cases. So just imagine these assets, for whatever reason, for whatever attack that happened, that this asset is shut it down. By the way, in terms of a glass industry or a steel or aluminum industry, it means you have to throw this because this is no more of use. Just imagine all the glass and the steel just, inside of it, what can happen. So deciding what are the critical assets, be it from the core processes, even from the utilities. We speak a lot with the pharma customers in Saudi and in the region. You may know that, especially in pharma, the utilities are as important as the process. When I produce drugs, when I produce medicines, I need to make sure that I have the right temperature, the right humidity, and the right pressure. So despite that those are not in the core operations, but utilities for me now, for specific sectors, are critical assets. So defining what are my critical assets is key in here to put the strategy together. And then, of course, after I apply the strategy, if I put everything together, how I know this is working, right? We heard of something called white hat, which are the ethical inflated, the ethical, if you want to say it, intruders to the network. This is where a team of experts, be it from Siemens in this case, will come and will simulate attacks with the different tools, with the different technologies to make sure that whatever technology has been applied is really proof. And similar to the digital transformation part, to the lean and green, this doesn't stop that you do it once and khalas, you're safe. No. This is as IT is. It has to be always continued. And that's why you see what I do in case of cyber attack. This is crucial. Most of us, perhaps even on personal life, whenever we open an email and click something we should not click or we've been hacked for whatever reason, the first thing we do is we shut down the machine. And there was a lot of resources or studies saying that if you shut down the machine, you make it worse. Because now you can't even trace it. And then it goes through the network. So what happens when there is a cyber attack? The first reaction is I get panicked as an operator. Because I use the new USB to put a patch that should not. And the second thing on the line is my job. I'll be kicked out. So developing standard SOPs to know how to react to these and to minimize the impact is crucial. And you see that it goes back and forth on measures, control, SOPs, impact, optimization. With that, I would like to welcome my colleague Ahmed Dursun to the stage. We'll have at the end just a Q&A session. Hopefully it was light.
It works?
Yes, it does.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Welcome everybody. Let me see if this works. I'm from Siemens Software. Nice to meet you. Originally from Turkey. It's difficult to get the stage from Mays. His great-grandfather was one of the viziers in the empire era. He's cool. But our solutions are cool as well. I didn't want to really make this session like what products we have and please buy them. Rather than that, I wanted to talk with you some concepts, right? I'm going to show how Siemens does it to give you some ideas. Doesn't necessarily mean that you have to buy from Siemens, right? The important part is that you get the concept. And maybe we can discuss on whether what we see is correct or you say differently. So I wanted to start with the design aspect, right? So if, for any company, right, you're either selling a product or you're selling service, yeah? So now let's look at the kingdom. I mean, we could focus our discussion into kingdom. What would be the kingdom's position, let's say, in years to come, right? Right now, the kingdom is the oil and gas giant of the world, right? Going forward, the kingdom is trying to diversify itself as well, yeah? Now, what will be the kingdom's position? Let's say you're either going to sell a product or a service, like we said, right? So if you look at, let's say, a lot of countries around the world, especially the bigger ones in terms of population, right? We have China, we have India, Pakistan, few hundreds, billions of people. Kingdom will not be in a place to offer cheap services, yeah? I mean, our population is like 18 million. I'm saying our because I live here as well. And with expats, let's say 30 million. So we will not be the cheap services country in the world. And in terms of products, can we say the same? I think with some certainty, yeah. With confidence, we can say that the kingdom will not be a place to be a competitive country for cheap products either. The kingdom should have a niche. And we have some examples from around the world, right? For example, if you look at Netherlands, in integrated circuits, they are the top of the world. They are focusing on some niche. ASMR is the one go-to shop, right? They have the know-how, they have that value add, and they can sell this to the world, and they are massively competitive because nobody has that know-how, yeah? Korea. I'll give you funny statistics. You know those big tanker ships that carry a like very big one, like 300 meters, tons and tons. In US, the major shipyards, they can produce a tanker ship in 6 months, more or less. In Hyundai Heavy Industries, HHI, they can produce one in 2 weeks. Look at the difference of know-how, right? So they have found their niche, and their value add is like next to none, yeah? So these are examples of selling a product and staying relevant in the market. It doesn't have to be, you know, any other cheap product, but there should be an idea, a value add, and the kingdom should find a niche for itself in the future if it wants to detach itself from oil and gas, right? So, and by the way, I'm gonna talk about this a little bit, but this discussion is, I think, kind of important as well. Then we look at newcomers, right? So I'm from Turkey, and we have almost no natural resources, almost none. No gold, no precious metals, no oil, no gas, nothing. If we don't somehow work, we die of hunger. Turkey is brutal. At the same time, Turkey's GDP is 1.4 something trillion dollars. Yeah? We don't really have anything to help us either. What happened? Actually, what we did was something close to similar to China and Korea and Japan. So we kind of followed the similar trend. We tried to copy what they were doing, just we did it bad, quite worse, yeah? If you're going to buy machinery, I mean, who would buy from Turkey if there's German equivalent, if the price is similar, right? Nobody. But we did it nevertheless, and we sold it cheap. Labor is cheap. We are like almost 100 million. It's okay. But we learned how to do it very good, yeah? Copied them for a long time. China did it similarly, right? So when we look at the first industrial revolution, the first one, 18th century, right? United Kingdom had to perfect it for 200 years just for Japan to copy it in 30 years. That's normal. The frontiers are, you know, they're far ahead. It's easier to copy them. Turkey did something similar. We copied it. Now we have a massive industrial base, yeah? And what we did was we copied it, but we learned it as well. Yeah, we now are producing industrial machinery that's on par with Germany. In some places, Turkey is, by the way, ahead of Europe as well, in some niche areas. What I wanted to show you, I mean, this whole thing was the product, right? So what will the kingdom do? And what are you going to sell? Either it's going to be a product or service, yeah? And we talked about that we won't be competitive in cheap services in the global arena. So it should be a product, a niche, right? And how do we do it? Yeah. So I wanted to tell you some ideas from product design, yeah? How you create a product and how you make it competitive or better. Tesla is a very good example that I'm going to touch base on in a while, yeah. So this is, again, a very Siemens blueprint. Give me a second. The second one, yeah, it's similar, but it's going to pop up some more stuff. Yeah. Okay, so this is how Siemens does it. But it should give you some idea. So in general, for a product to come to the picture, you should have an idea. Yeah? It should be an idea, a requirement, a need that would fill some place. You start with that. It should be features, requirements, parameters, whatever. We are going to design something. That idea will be then realized via mechanical, electrical, and software design. And look at automotive. By the way, look at something very simple like a coffee machine. It has mechanical design. It has electrical design. It has electronics design. And it has some software. Pretty much anything. Back in the day, most of our customers as well, I mean, the world is revolving kind of slowly. They were doing all these, by the way, I'll try. Does it have laser? Laser doesn't work, sorry. So I'll point it with my hand. So we would have some ideas, and then we would do these design disciplines. Bi-iznillah, inshallah. Expect that it would all work together. Typically it doesn't. Because what we have thought would not be translated to the design teams very well. And what they design will not be working at the first step either. So this link is broken at the start, typically. And then let's say that the design teams did it. It's time to see if these designs are working, right? You start simulation. Typically it doesn't either. So this cycle goes back all the way to the start. We do it again. Inshallah, this time it will work. It doesn't either. So this cycle will continue for a lot of times. And a lot of effort will be lost. Now, how do you stay competitive is if you can manage to shorten this cycle, if you have platforms to keep everybody working together, then you will have a faster design to market, and you will have more products, and you will be able to answer the market demands shorter. This, we call this product lifecycle management, but the idea is quite simple, right? So design, I mean the idea, the design aspect itself with simulation and system physical testing should be all together. So this will typically, by the way, this is more of a, how do you say, a bit more advanced stage, because typically countries start with production first. You try to copy. You get the designs and try to copy. Even if you do it, all of these elements will be there at some capacity. So the idea is to get all design aspects to create a product interlinked together. I'm not going into all the solutions, what we do, what's the technical details. It doesn't matter really. The idea is that we have a PLM system, a product lifecycle management system, that you start from the idea to manufacturing in the same platform. Aerospace defense is a very mature and a complex industry, by the way. Yeah. So this idea is applied in aerospace defense very well. Actually, they're like the frontiers of the world, if you look at it. So they start from the requirements, the idea itself, before even designed, will be modeled as systems, and then it will be designed mechanically, and then it will be simulated. Otherwise, creating an airplane, by the way, will be nigh impossible. If you try to do it in a traditional way, just to give you some ideas, the older jets would have like 15 to 20 years of development cycle. From the idea that the US government would give a go-ahead, start working on this jet, it would take 20 years for them to manufacture it, because it's difficult. But now it's not that difficult. Just to give you one example as well, Boeing doesn't use any paper-based drawings. If you go to Boeing, from idea to manufacturing, you'll not find any paper works. No paperwork orders, nothing. Everything is digital. So that was a design part, yeah? Let's say that we have a product, we have an idea, how do we manufacture it? It's the second step, let's say. And now, this time, you, let's say, finished your design, you have an idea, but you designed it. Now, how are you going to manufacture it? How are you going to plan to manufacture it? How are you going to manufacture it, and how are you going to serve it? Because this whole cycle, again, you could be doing it in a traditional way, old way, and it's going to be very ineffective. Or you could do it in an integrated way. And this is called closed-loop manufacturing. The idea is, I think, kind of similar, yeah, in design. So basically, it's like following the Industrial Revolution. First, it was steam. What did steam achieve? It converted human labor to mechanical labor, right? It was saving efficiency on human. And then it was electrical revolution, which increased the efficiency of steam as well. Then it was automation, which again increased the efficiency. You remember Maya said that Siemens factories has become 13 times more productive, 13 times more in the same space. It's just trying to go with that efficiency. And this closed-loop manufacturing is pretty much the same idea. So we can look at it in a bit more detailed way on how Siemens sees it, yeah? So there's going to be a product design. You start from there. So we're going to be planning on how to manufacture this product, yeah? How are we going to machine it? How is it going to be assembled? How are we going to design the lines, yeah? Then how are we going to execute it? It's going to be all, I mean, our solution set gives that idea that we are going to tie all these together. Then there's going to be quality planning and execution on, you have the design, how are you going to push it to the shop floor? This again is going to be linked. Then obviously there are some auxiliary disciplines as well, like how do you do the supply chain, how are you going to do the data management, change management, so on and so forth. But the idea is you have your factory, right? You start from product design till manufacturing, all of it, again, intertwined. This is kind of a visualization of how this comes. A product comes here, the design, the idea of the product, and then raw materials come. You make these two together to create a product, and you deliver it, right? Let's move one step ahead. There's some, so the idea is, of course, to get this interlinked together, yeah? But how do you do it? It's easier said than done. We have 20,000 products, 20,000. It doesn't make sense to go over all of them. Just the idea of getting everything connected is important. In this scenario, for example, before doing a plant, we simulate how the lines and the plant layout will be, even to the point that the operators, the humans, are going to be simulated. So before you design your plant, you see how efficient it is. You try every scenario, because building a plant is expensive. You cannot do it many times. You have to make it right from the start. And if you fail from the start, you're going to end up with a plant that's inefficient for a very long time. We can do all of these together. Maybe we can, yeah, this slide kind of shows how it is. Typically, the design part was, yeah, we talked about the product lifecycle management, the PLM part. ERP is a very common terminology. I'm not going to go into it. Obviously, all companies would have an ERP system to manage their financials and inventory and orders. Now, the MOM part is what I was trying to explain from the previous slide, where it's the product idea that is combined with an ERP system with orders, with financial data, will be pushed to manufacturing. And this cycle will be done without human interference. Yeah, you receive an order, you log an order to your ERP system. It will know exactly which product, how it was designed, and it's going to know how it's going to be manufactured, and it is going to do the manufacturing again without human intervention. Now the IoT part, I'm trying to go over slides a bit quickly to save time. So the IoT, I think it's rather easy to summarize IoT. What you cannot measure, you cannot improve. And I think it's kind of a good summary of IoT in general. Why would you want an IoT system? What's the value add that you're looking for? Why would you get an IoT system? To do what? Now, at any point in time, a factory would have metric loads of automation tools, machines, sensors all around, auxiliary stuff like even running doors, AC, whatever, yeah? And the point is to keep this factory running. That's the first priority. The second priority is to make this more efficient. Now, how are we going to do this? We need to gather data, right? It's kind of simple, I guess, since we are talking about IoT. If we manage to gather all the data, we can start from simple tasks and move to complex tasks. The simple task, what could it be? The very simple task is that I can make sure that everything is running. And I can make sure that if something is not running, I'm aware of it. Yeah, this is the first, like the basics of IoT. Alarm management. Now I know everything from running doors to AC to complex machinery, lines, press machines, whatever. Yeah, the whole factory, the mixers. If anything is not running, I'm aware of it. That's the first one. Yeah. Now we made sure that it's running. Then what? How efficient are we running? If I can measure this, it's called overall equipment efficiency. If I can, where is it? Yeah, this one. If I can measure how efficient my machines are in manufacturing, where they are stuck, what's their problem, I can improve it. Yeah, it's not about only stopping or not. How long was my press machine waiting for the previous one? Where was the bottleneck? Why is not let's say that in the drawing board, I calculated that I was going to produce 100 coffee machines in 1 week. At the end of the week, I produced 74. Why? Where am I stuck? Yeah. Without an IoT platform, it would be very difficult to get this data. Now, if you know how efficient your factory is, you can start improving on it to track where it's failing. Let's move one more step ahead. Energy consumption. Every major factory, especially in some industries like metals, chemicals, they're burning through energy. It's major spending of them. How are you going to improve it if you don't really know where the energy is spent? Yeah. By the way, IoT is it's very, how do you say, very trendy in the sense that I want to measure something to improve it. I want to measure something to improve it. That's the idea. Energy management. If I know where my energy is spent, I can first of all control it, and I will not have shocks about how much I'm going to pay for it. But it doesn't stay there. With the Insights Hub, I mean, our IoT platform, we can do energy optimization as well. We get the data, we know what we are spending now. We can go further and put some AI models in there to say that take these actions so that your energy expenditure would be 5% better. Yeah, if you're spending $100 million, that 5% would be a $5 million saving. It's massive. Then IoT platform would also give you quality prediction, which is, these are all advanced use cases, right? We started from alarms, yeah? Is everything running or not? This is how the game is. Once you conquer the first steps, you go into more complex scenarios. We looked at efficiency, how efficient we are. Now we are controlling energy. Next step, we can predict our quality as well. If any company in production business, manufacturing business, is very careful about quality, right? If your customers are not happy about the quality of your products, you either start losing market, you either start losing money with refunds and repairs, yeah? And you start losing reputation. Quality is a critical matter. Now, if you could control your quality, if you could predict it reasonably well, then you'll be ahead of your competition just like that. These are not easy to achieve steps. Yeah, the more complex what you want to achieve, the more difficult it becomes for both the vendor and the customer to implement it. Just let's be honest here as well, right? You start from the basics. Basics are kind of easier to do it, but to achieve the more difficult stages, it requires maturity from the customer as well, and the buy-in from the customer as well. So this is kind of, in a nutshell, IoT platform. We try to measure something to make it better. This is just the, by the way, I'm sorry. Do you hear me well still? Okay. This is just a high-level architecture of an energy management solution that we have with IoT platform. So I said that I'm from Siemens Software, right? Maze is from Siemens Automation, and together we cover pretty much the whole stack. It's just not a software that we give it to you and say ma salama. On Bilax, yeah, I forgot the English. On the contrary, sorry. We start from the sensor level, from shop floor level, and build the whole stack with you. So that you, when it comes, for example, energy management, we have this. Is it falling? Okay. Still? Okay, sorry. So we all have the full stack with you. We can sit down with you, focus on your needs, see where the maturity of your plans, and build this together. This will be the last technology stack that I'm going to be talking about, and this is the logistics part. So I want to make it quick, right? So this one is more about how to manage the supply chain. So any big company would have massive supply problems, and a supply chain problem is not only buying stuff, but it's also delivering stuff. Especially if you start going, if you become bigger and you go intercity inter-country, international, right? So the supply chain, it becomes a problem of itself. No company in the world, to my knowledge, maybe except Aramco, produces everything by itself. Even Aramco, yeah, it produces the oil, but it has to buy the machines, right? Even natural resource companies, they have massive amounts of buying, because in order to facilitate your factory, you have to rely on a lot of technology providers, raw materials. No company can produce everything themselves. So buying everything and making sure that everything is arriving on time, in a timely manner, which doesn't affect your manufacturing and production, is critical, as well as dispatching it. Yeah? If you don't manage to put your supply chain in a streamlined manner, your production will be failing left and right, guaranteed. And you'll be losing a lot of money. Because if you cannot keep your production almost running at 100%, you'll be losing a lot of money. Workers are expensive, running factories are expensive. Time is money in a lot of different ways as well. Opportunity cost, yeah? So you have to make sure that whatever you're buying is coming on time, as cheap as possible. Similarly, whatever you're selling should be reaching your customers in the time that you have promised. If you promised that it takes 6 months to deliver these machines, and if they're calling you in the 9th month to say, where are you guys, that customer will not work with you again. Or very low probability with that it would. In Siemens side, this whole supply chain management is again thought about a single, let's say, technology stack. It's not single technology, or it's not single application. Again, yeah, this is just a repetition of what we had said. So that would be the end of my presentation. Nice, back to you.
So we'll hold you no more. This is just last few slides. It's picked some of the references that show how technology can make a difference, right? Nothing commercialized. It only shows in different aspects in day-to-day life how technology is in Industry 4.0 and Siemens are shaping the future. So basically, this is when it comes to the productivity speed. As I said, we were able to produce within Siemens 13 times more. This is Siemens, right? Now we're talking about other customers, DMG, Mori. I think we all know this company, right? And this is where they have built a full digital twin of their factory, end to end, right? And they were able to go 40% faster ramp up. This is an example. Another example was related to BASF. Again, another chemical processing factory. It's all about speed, time to market. This is a crucial part, right? And how much they were able to shorten their time to market on this. Another example that, and in fact, this was in GITEX just a couple of weeks ago in Dubai. We see, unfortunately, with the geopolitical and the wars that are in the region and globally, typically how much is a prosthetic arm is costing today, or a limb in general. It's anywhere between $50,000 to $100,000. Siemens started 3 years ago a program with one of our partners on how to make this in a single-digit number, anywhere between $1,000 to $10,000 for a hand, for a limb, for a leg, right? And that was the whole idea, is how we can build a full prosthetic limb, arm, leg, whatever the case, in a digital environment as a digital twin, tested, validated, and it's not kind of the shelf that, and this is the problem with prosthetics today. If la samahullah, someone needs a leg or an arm or any limb, he has to go there, he has to try to fit it, adjust it. No, today with the technologies of digital twin and with additive manufacturing, what we call 3D printing, we are able to help our customers and to build like individual limbs and prosthetic parts for the end users, for the fraction of the cost that used to be. As I said, from $50,000 to $100,000 is today is 90% cheaper. And 3 weeks ago, it was shown in GITEX, where we are able basically to create almost a full hand, so 5 fingers with the cap from here and all the way to the elbow for less than $5,000. This is how technology can make a difference, ladies and gentlemen. And this is an example that is really interesting. Why? Because we're suffering from this, and unfortunately this is not really a nice story to tell, but this is where technology can make a difference, a big difference, right? Another example that we have in here is related to the packing machine. I don't know if you have noticed recently in many of the customers, there is no standard pack size anymore, right? If you buy from Amazon or Noon or Souk or whatever is the case, or any other customers, you see that the packing itself is as size of the container inside of it. So there is less waste, makes more sense, less cost. Because if you're buying a small item, why it needs to come with a standard cut, right? So this is where simulating this in a digital twin concept will help. This is one of the technology, again, related to digital twin. Speaking about 50% shorter time and 20% less energy consumption, right? When it comes, for instance, to the chemical industry. Why I'm saying chemical industry? Because this is where the competition is really going tough, especially with the new entry coming from China and from India, right? So even the existing, be it in the GCC, in the MENA, or the whole Europe, there is a big push to modernize, digitalize, and lower the operating cost in there. One of the key success as well that is, I think, mashallah, in the kingdom as leading this is the vertical farming, right? How with less water, less resources, I don't even need the soil. I'm able to have, I'm not saying 10 times the production, I'm going to say 50 and 100 times the production of the conventional way on how we irrigate and how we culture our food. Is not only about price. Food, as you know, it's a national security. You can afford perhaps to stay without a car, without electricity, for certain, without internet perhaps for some time. But when it comes to food and water, this is we go to the basics. And this is where technology, digitalization is helping, you see 300 times more food per foot square. 300 times. Can you imagine? Especially with a place like in Saudi Arabia where it's mainly desert and the region where we have scarcity of water. Main water source is desalination, which costs a lot of money and efforts, and it has its own impact when it comes to the salinity ratio in the sea. So 300 times I can spend in 1 meter what I used to plant in 300 meters, right? And this is with today's technology. Another example was for the wastewater treatment, and we know, and we are engaged already with Saudi authorities, be it Saudi water authorities or national water authorities in here, on multiple topics on how to improve the water treatment, how the water can be reused, not only once, couple of times, and to what extent. In some places, especially in the Scandinavian countries, I would say the sewage water is not only used for irrigation water. There was reached a level where this water can be reused for even direct human consumption. Perhaps it has some different approach in here, etc. But it tells where the technology is driving when it comes to reusing the water. We all say that oil is the black gold, right? But with the scarcity of water we're having, water will be very soon is the real conflict. And we see nowadays start the conflict on water. It's already happening. It's not futuristic. Again, when it comes to energy, and there was a very recent project, I was part of it, that we've done for a major fertilizer producer in Jordan. And it was really impressive to see with just less than $1 million investment, they could have 10% improvement, over 10% improvement of their energy cost. So their operating cost is around $1 billion per year, and energy is 40% out of that. So they spent $400 million on energy. And 10% was something that we were able to save. So the ROI was a matter of weeks for that client, not even months, not even years. Exactly, this is another example when it comes to digital workers. This is back to what Ahmed was mentioning about how we can design things in a digital twin aspect, and then how we can make it virtual product, virtual operation, and actual product. And of course, when it comes to developing time of all electric composite aircraft, for instance, right? This used to be years of work. Now it's a matter of days for the certification process. And mashallah, SEER is the front runner of this, and we are engaged in SEER on the specific topics. And of course, another topics, perhaps we all heard about vertical farming, but I don't know if you heard when it comes to sustainable underwater farming. That's another as well topic that is now booming big time. Because, down the line, our continent is 70% water. So whatever land space we have still is tiny compared to, the sea and water space that we have. So there are a lot now of startups, initiatives on how we really can make use of this, right? And here where we're doing full digital twin for subaqua biosphere setup. The whole idea is to be able to virtually commission a full plant while having nothing on the ground. This is really nice. Think about it as nowadays, even if you want to build your house, you are able to even walk through it, right? They put you this VR and these advanced places. You can go through it. No, this room doesn't fit here, move it in there. This is basic. Now with the factories, we are doing what we call virtual commissioning. So we take the plans, the PNIDs, for instrument, electric, mechanical, etc., even the people, the movement that Ahmed showed a minute ago, and then we let it go, start operating, and then we identify bottlenecks, and then we go back and change the design, because with this specific design, I'm having a bottleneck in here. Perhaps a truck is having intersection with a pedestrian or whatever is the case. So all of these rounds are done, click of a button, and then you reshape, you improve, you reshape, and do it right at once and first. And this is the concept. This is another examples on, with some numbers, perhaps that it could add some value in here. This is a company, Electrolux. I'm pretty sure most of us use their products in a way or another. Is basically how to test these machines before they use the end customer. Quality was point Ahmed mentioned big time. Today, we have reached a level where when it comes to the supply chain part, the cost of items is clear. So either you differentiate on a price and product price or on quality. So it depends on what's your market, right? We're all now talking about the Chinese cars. Chinese cars used to have a reputation of quality issue. It's no more there, right? Now, Chinese car is as good as European cars, and even European cars now are struggling. How are we going to compete? So such technologies, when it comes to the efficiency, is no more nice to have. There is now big move within Europe on how to make these factories really top tech factories to reduce the operating cost so they can compete with competition in the market. So with that, we come to an end of our presentation. Hopefully it was smooth, fruitful. Thank you very much for your patience. Barakallah fikum.
Thank you. Thank you very much, Ahmed. Thank you very much, Mayez and Ahmed. We're very glad to have you in here. And thank you to the Siemens team as well. You've shared a lot of valuable ideas on how digitalization, automation, and energy management driving both efficiency and sustainability in the industrial landscape. Now we'll move into the Q&A and open discussion. Just have a moment.
Sure. Yeah. Imran, please join us.
I'd like to invite Mr. Mohammed Imran and Mr. Ahmed and Mr. Mayez. Please, now all the questions and comments from you guys. Please feel free to share your thoughts, and let's keep this discussion alive and interactive.
I have a question for Mr. Mike. You showed us some examples where Siemens has helped the clients with your solution the example was like where you helped the smartphone company to shift ventilators. They could produce 55,000 ventilators in a week's time. So how much was the total financial implication for this solution compared to the total project cost?
That's a very good question. And since it is not showing you there, it's not a public information.
Yeah, that's why I said if possible as a percentage, roughly.
Percentage is anywhere between 40 to 50%. This is where typically we're going on.
Okay, of the total project cost.
Yes. I mean, this has been instrumental on, as I said, on the minimum level, on the big projects, on designing of the products, the actual product itself. And not only that is on the part of the supply chain part, on sourcing the raw materials.
Yeah.
For whatever reason today, if I'm using nickel, right, for this specific part, what if today, for whatever reason, there is an invention and nickel is 10 times the price I know? What is my option B? So it's not only about the simulation of the material itself or the process itself, it's even on the meteorology of these spare parts or aspects. How I can move, for instance, from nickel to, I don't know, iron steel or stainless steel. Does it make sense? Technically, financially, etc. So it's giving our customers endless options on how to mitigate conditions that are not foreseen as of today. Because last thing you want to do is you build something, you patent it, right? And then you start production based on specific cost. We also, after the electric car hype, the cost of the lithium that went over 10,000 times now, right? It's price is ridiculously high because of the supply and demand issue. So just imagine if part of that's done.
One more question here, Sam. So you also guide them with the vendors, or no, you just give the solution, then it's up to them?
Yes, it is more about the technology provision itself and about empowering them on how to take these decisions based on science.
Thank you so much.
Most welcome.
Thanks, and the presentation was very insightful. I have a question related to cybersecurity. Now, the data, which is like in any manufacturing, we have IT and OT, right? So now, for the data which is generated or created in IT may be a small part. The data which is coming up from OT machines and all, it'll be like a humongously huge. Every second or every minute we capture the data. So now the amount of efforts which are spent on IT is huge. What do you see like for OT, like the cost-wise and then the attack-wise which are happening, for especially for machines, and then the security layers which are being, which we have so many in the market. So now, can you give more insights on this one?
Okay, that's a very good point. I would like first to highlight that the first time in 2023, there is an IBM basically yearly report about security and cybersecurity. And in 2023, it was the first time ever that the attack impact and cost and focus on manufacturing was more than financial institutions ever in the world. So there was a big shift from the cyber attack, from financial institutions, which mainly banks, etc., to manufacturing. It's not because manufacturing is wealthier and they have more money to give, no, because they are not prepared for it. This is where things started really to say, okay, now it's not only that attackers and intruders have now identified that financial market is now kind of robust, is they have identified that the next target for them, which has become now number one, is definitely manufacturing. And one of the parts related to data being generated on the site, of course, as you said, it's a high frequency. And it goes way larger than the IT network. That's definitive. But what we have come as a technology is there is no need always to shift all of this technology to the cloud or to the decision-making level. What we're doing is in most of the cases, we are providing industrial edge devices. And those edge devices has the capacity to analyze the data and to transform this data to knowledge on the data source itself, which means less traffic on the network. That's one part. So first, think of it from just physical security perspective, right? If you have a road and you believe there is an intruder that is coming this way in his car, the first thing you're going to do is what? Minimize the traffic. So the first thing we're going to do is, do I really need all of this data to come to my cloud or to come to my enterprise layer? It can reside on site, it can reside on the edge device, it can be treated over there. I only can take the KPI and the data or the information, what we call knowledge, out of it that I needed. That's first. Secondly, the industry has developed what we call IEC 62443, which is an industry focused on best practices for OT cybersecurity from both an operator side and from a vendor or service provider side, on how I can make sure I mitigate and what systems I need to have in place, what kind of an audit needs to have. It's like the ISO when it comes to the IT part, but however, it's focused on the OT part. Besides all these times, Siemens has coupled with, I would say, OT and IT leaders when it comes to the actual physical hardware of it, which is basically when it comes to Nozomi, for instance, or the firewalls itself, the intrusion detection systems, the traffic management systems. Because today, there are different layers of how I can identify an intruder, right? It could be all of a sudden, high traffic on my network. Something doesn't make sense. I'm speaking of OT part. It could be that this machine never spoke with this machine. Why now there is a new connectivity that is happening within my system? So despite this looks like a legitimate communication between two systems that are governed by my IT/OT rules, however, the system is able to detect a new network that is being established between two parties that never spoke to each other before. So the level of technologies that have been developed within Siemens in particular when it comes to the OT, because this is where we come from, right? Electrification, automation. So we understand how controllers, PLCs, how HMIs, how sensors talk to each other, how systems, SCADA systems, and we have developed technologies for the intrusion protection system, for the overall OT cybersecurity that are helping our customers to make it to a great extent proof. But I would say it all starts with segregation of the networks, tagging the networks, and we have one of the nice tools, perhaps we didn't cover it today, but I can share it with you offline.
Definitely.
Exactly. One of the nice tools that it gives like the overall health status of your OT network. Even if someone decided at any time.
It's a lot. And they think about if I have to go and do the connectivity and patching and analyze all this, man, I'm gonna burn a project money, right? If I get attacked, it will be maybe less. Why bother? I don't want to be the Siemens sales guy. However, I'm gonna be for a few minutes. The industrial edge product solution that we have, it has embedded Synex security guard against from Siemens. It finds vulnerability. So you do the connectivity to your OT, right? It will go and inspect and find all the vulnerabilities automatically without you doing something. It will map it to asset hierarchy and offer you mitigations. So that scary project of doing, oh my God, what am I doing? How long it's going to take? It's Siemens streamlines it very well. So you don't have to be that scared.
And just on top of that, it goes back to the fact that is built secured by design. The days where we build the product and then we try to attach security protocol on top of it is no more viable. The security protocol, the way that it speaks to other systems, it has to be built in. So it's not a top-up on top of the product or service. It is embedded part of the product itself. Welcome.
Okay, I'm really delighted to be attending this lovely seminar full of rich knowledge. I have a question on client-wise. If the client came to you with an idea already made, do you already develop it with the right technologies, or you just suggest something to him? Or if the client came to you with no idea but to want to invest his money, do you give him idea about the needs of the market with the studying and so on? The other question is on the cycle of despair. How do we stop the cycle of despair with the low cost as possible?
Yeah, that's a good question.
That's a
So
loaded question.
for the first part, Siemens 3 years ago created something called Accelerator. I don't know if you heard of it. So this is our platform where we are inviting pretty much our customers, our partners, startups, you name it. You mentioned about the new ideas, etc. Even investors to come to a marketplace very similar to what you have today in the digital era, where you can buy from, day-to-day shopping, for instance. But this is more on industrial aspect, where startups, companies, vendors, even for that sake, sometimes competitors, head-to-head competitors with Siemens, because we believe in this inclusion part, that despite we are a Siemens, we cannot do it all together, all alone. So our extended arm as a partners, and this platform, they called Accelerator, it empowers especially startups to be able to shape, okay, I have an idea. The problem typically with the startups is not only about the idea, right? We can today speak $1 million or $1 billion idea in this room, and when we leave in the afternoon, nothing gonna happen. The magic starts when I find a way to make this idea real. Which technology? Is it doable? It's not doable, because sometimes you have an ideas with today's technology is not doable. And back to what Ahmed was showing as software or solution pack, from the ideation part, from what I needed for the parameters, the target, the whole concept itself, is it doable? Because sometimes perhaps mechanically is doable, electric is not doable, instrument-wise is not doable, or security-wise is doable. There are lots of combinations. So this platform Accelerator is a great tool, and we see in the last SPS Smart Solution that happened in Germany, Nuremberg last year, we were pleased to have over 100 startups hooked with Siemens, and we're helping them to really move these ideas into something commercially viable. And we're not only doing this with the startups, even with universities. And we have a footprint even in the kingdom in here, with helping even universities with the solutions on how they can, because I think the fresh minds like yourself and fresh graduates, this is where the out-of-the-box ideas are coming. So we're starting even from there, from startups and from universities.
And for the cycle of despair, how to stop it or minimize it to the lowest?
Do you want to?
Yeah, sure. But before answering you, I would like to touch base on the previous question. So there are two aspects of it. First is, if there is a customer who needs to know what he has to do to produce, for example, is it viable or not, what is the market demand, and how to achieve it. So this part Siemens does it via a branch of us called Advanta. These are the consultancy arm who have the know-how of doing the market feasibility study, the product design side, as well as the execution part as a consultant to prepare the design blueprint and then give it to the customer. They can bring in, example, a company who can really execute all aspects of it. Second part comes where Maya's added about accelerator. So, say example, in the industry there are 100 companies and different application integrators who have expertise, one into aerospace, car, petrochemical, you name it, whatever it is. And they have achieved a solution using the platform, say example Siemens here, or third party even, that has proven itself worth, it can produce results. So this application brought into Accelerator, which is like a marketplace, Google Play Store or Apple App Store. And when any customer needs a similar application, or a developer even needs to do something more, add additional layers of technology, they can collaborate together and make use of it. So this is how it is done. Okay. The other part about spares, which is a very, I would say, important question in Saudi Arabia, and we have come across. Maya gave an example. There is a PLC called S5 series. If you Google it, it was in the market in 1979. Okay, and it is still running in Saudi Arabia, in many, many places. It is such robust. But the cost of maintaining and keeping an inventory is too high. So the best practice here is that companies should ensure that when they are buying or investing into a technology, it must be latest in the market, and they keep cycle of upgrades. Usually the hardware in automation side is 15 to 20 years time. Okay, so what anyone has to plan is that to do the capex investment initially, and then opex investment to upgrade these technologies over the period of time. You can do it partially. For example, the main processor, you leave it as it is. The ground sensors, you can change it. And at the end, touch base on the latest hardware. And use whatever is left over as your investment. So this is how it has to be done overall.
Thank you very much
Thank you.
for your insights. As we conclude today's session, we'd like to extend our gratitude to the Siemens team and for their leadership and continuous support in advanced manufacturing sector.
Thank you
Digital
very much.
innovation.
Thank you. Thank you. Barakallah.
Thank you. Please be seated.
Thank you.
And now I'd like to invite Mr. Ahmed Al-Baghawi, Vice President of the Studies Department, to give the awards to our beloved guests. Kindly, Siemens team.